I just got to check to see if the sound switched. It did. Okay. I'm seriously thinking my computer doesn't like my AirPods.
I can't get my AirPods hooked up to my computer.
Because when I'm using these, it works fine. But these hurt my ears after so long. Okay. So Linny and George, if you don't know, Linny and George is from the book Mice of Men that you guys read last year. So it was part of the problems out of the book. Are still wanting to raise rabbits, but this time they're going to start with 2 rabbits, and each pair will have 4 new bunnies each month. How many rabbits will they have after 7 months? So since it looks like not most of you watched the video, we're going to start with a diagram. Okay? So they start with 2 bunnies. After 1 month, they've had 4 more bunnies, right? So how many total do they have? What's 2 plus 4? 6. I'm going to make a table here. So this is month and rabbits. Okay. So at 0 months, they had 2 rabbits. At the end of the first month, they now have 6 rabbits, right? Each pair is going to have how many more? 4 more. So this pair is going to have 4, this pair is going to have 4, and this pair is going to have 4. So that's 6, 6, and 6. How many total rabbits do they have this time? 18. Are you seeing how I'm doing it? Because it's each pair has 4 more. It's not going to be just 7 times 2. Now, I'm not going to draw out all 9 pairs. But we talked about how prior to this, we worked with lines where slope added the same value every single time, right? It was a consistent value that was added. Are we adding the same number every time? So this distance here is 4. If I add 4 to 6, am I going to get 18? No. But if I'm not adding by the same amount, what am I doing to go from one to the next and go to the next? Does anyone see the pattern? Multiplying by 3. So we talked about yesterday that these are exponentials. Exponentials multiply by the same value. So if I wanted to go to the 3 months, so this is times 3 times 3. I'm going to times this by 3. Okay. 18 times 3 is 54. Do it again for the times 3, 162. Times 3, 486. 6 times 3, 1,458. We had a good laugh about how many rabbits they would make. They would have times 3 again, because I said 7 months, right? Times 3, 4,374 rabbits. That's a lot of rabbits. I think the problem we did yesterday in a year, it was like 4 million.
Yeah.
4 million rabbits. Okay. These are exponentials. Exponentials are multiplying by the same value, whereas lines were adding the same or subtracting the same value. Okay. And since I only know one person, was the graph a straight line, Hayden? Do you remember? No. What shape was it? It was a curve. It looked like this. It's kind of hard to see those dots, but it is a curve. Okay? So this is the first time you're going to be working with curves. Also, I'm going to swipe this back. We talked about something called discrete and continuous. So there was a lot of information yesterday. Discrete variables are things that you do where you do not connect the dots on a graph. Things like that are items, like people, rabbits. Because can you have a half a rabbit? No. Can you have a half a person? No. When you connect the dots or connect the points, that means you are having partials of something. I could have a 1.2 or I could have a 3.4, something like that. Those are measurements. What's an example of a measurement? Just in general, what's an example of a measurement? Say what?
Bank account. No?
Money,
Money? Money.
money, yeah, money. You can have a decimal of money, right? Time. Time is a measurement, like 3.5 minutes. What else? How many of you had to run the mile yet? Only one?
Some of you don't have PE.
Don't have PE yet. Wait till you have to run the mile. That's a measurement, right? Okay. So measurements are going to be what's called continuous because you can have a decimal. When you're talking about a thing, you're going to have discrete or separate points. Okay. Questions. So you may want to go back and watch the video from yesterday. Lots of information in there. Lots of information. Questions on your homework? Okay, no? All right. Now let's talk about your ESA last week. Most people did pretty well. But some of you still have ESAs to clear and the I want to say the quarter. It's the semester. We're halfway through the class. That ends on the class. This semester ends on Friday. So here's a couple of things, guys. I'm going to give you, if you need to clear an essential, I'm going to give you one shot on Friday to do it. Okay. This class will not be here on Friday, will you? So you'll have to zoom in at 2:40 to do it. It's a one-shot thing to try and clear it. If you've been working through all the practice stuff, I would keep doing through the practice stuff. If you think you're going to sit in on one shot without looking at any of it or practicing any of it, ain't going to happen. So if you've been working through the practice stuff, keep doing that. Don't wait. Don't procrastinate and wait till Friday. But also realize if you still haven't got it passed by Friday, you get to make it up after that. Okay. What will happen is you'll get a no credit on your report card, but as soon as, because the report card's really not that important. What's important is your transcript. Your transcript is what stays with you with your credits. Okay. If as soon as you clear it, I write what's called a grade change and you get your credits on your transcript. It's as if the no credit never existed. Does that make sense? Okay. All right. So keep that in mind. You get it. This is a one-year thing. Normally in a normal year, once the semester ends, you don't get to make it up. And then you have to repeat the class, but not this year. This year you get a chance make it up. My brain went flat. Okie dokie. Any questions? No questions whatsoever? None at all? There's always some questions, especially from freshmen. All right, so I didn't put the problems up there. Let me get them up. We are going to be doing problems out of the book again. I personally like this chapter. So (1831-35). It stinks. So with me, we're going to do 5-18, 31, and 35. Oh, wrong computer. Then your homework's 22, 23, 25, 36. So you have 4 homework problems, and we're going to go through these three in class. But this is, Ms. Longo, this is the one activity you and I like to do, right? Because it's fun. But we can't do it this year because you have to work in a group. Yeah. So I think I have an idea. So I want you to get your stuff out and go to problem 18. Let's start with 18. I hope I've got this. Come on. All right. Many games depend on how a ball bounces. Would you agree with that? Baseball, how the ball bounces. Anybody play soccer? How that ball, when you kick it, how it bounces, right? It's got to have a little bit of a bounce to it. Anybody play basketball? Golf. Seriously? Nobody plays? Okay, tennis. Anybody play? The way that ball bounces is important, right? For example, if different basketballs rebounded differently, one basketball would bounce differently off the backboard than another. This could cause some basketball players to miss their shots. Would you agree? That would maybe give an unfair advantage. This kind of goes in, so like if the ball was inflated too much, then it would bounce probably more than if it's inflated. You ever had a flat basketball and tried to bounce it? It doesn't bounce, does it? No. So there has to be a certain amount. Who remembers a couple of years ago, it was called where the Patriots, the footballs weren't inflated to the right amount. Remember that? And they're like, what's the big deal? Well, it throws differently, doesn't it? Person catches it differently. Because if it's overfilled, it's harder to grasp. If it's underfilled, it's really easy to grasp. I don't remember what it was called. Airgate? I don't remember. But everybody kind of remembers that, and that Patriots got in trouble. So that is what happens with this stuff. They have to test their balls so they meet certain standards with the bounce. We're going to investigate the relationship between the height from which you drop a ball and the height which it rebounds. So listed below are the bounciness standards for different kinds of balls. A tennis ball must rebound approximately 111 centimeters when dropped from 200 centimeters. A soccer ball must rebound approximately 120 centimeters when dropped from 200 onto a steel plate. A basketball must rebound approximately 53.5 inches when dropped from 72 inches onto a wood floor. Squash balls, everybody's like, what's squash? I'm not exactly sure what it is. It's an interesting. Must rebound approximately 29.5 inches when dropped from 100 inches onto a steel plate at 70 degrees. Different standards, right? Discuss with your team, and that's going to be us as a class, how we can measure a ball's bounciness and which ball listed above is the bounciest. How can we determine? So we're going to brainstorm. How can we determine the bounciness of a ball? Ideas? I'm not going to give you the answer. You guys are going to tell me. How would you think? How would we figure out how bouncy a ball is? Everybody's kind of like, just take a guess. It's not going to hurt to take a guess. Okay, well, they gave us some numbers about bouncing, right? How could we figure out which one is the bouncier one? Okay, it goes higher. Okay. How can I determine which? Because they're in inches and centimeters, right? So some of the numbers are in inches, some of them are in centimeters. How can I determine which? No guess? That's a cool one, Anthony. I like that one. He's got killer whales like in a like Puget Sound area. Looks like cool. So let's go back to my numbers. I'm gonna pull out my book because I'm not gonna tell you. This is where we're gonna work on this together. So a tennis ball. So let's see. So tennis must rebound approximately 111 centimeters when it's dropped from 200 centimeters. Okay. So, well, let me give you a hint. About how far, so if it's dropped from 200 and it bounces 111, it's bounced about how much? If it starts at a 200, it's about half. Would you agree with that? How can I get half from this? How can I find out the exact, how can I do that? Divide it. So if I took 111 divided by 200, that gives me 0.55. So it bounced back 0.55. Okay. Could I do that for all the other ones too? Okay. So let's do that. The next one is a soccer ball. It rebounds 120 when it is dropped from 200. Okay, so what's its rebound? You guys need a calculator? If you need a calculator, get it out. What do you get? 0.6. So 120 divided by 200 is 0.6. So is it bouncier than a tennis ball? Huh? Yeah, because that number's higher, isn't it? It came back higher. How about a basketball? Its rebounds is 53.5 when it is dropped by 72. So we're going to do the same thing. .74. So the basketball's bouncier, isn't it? Would you believe that of the three, that the basketball is pretty bouncy? It has to, right? You do the squash. Its rebound is 29.5 when dropped from 100 inches. Well, I can do that. It's 295. So which of our four balls is the bounciest? Which one's the bounciest? The basketball. Now, could I use this method for any ball, you think, to determine how bouncy it is? Okay. Can we come up with it like a little formula for ourselves to see how it rebounds? What would be your formula? Rebound is equal to? Or do you want to say bounce? It's called, by the way, it's called the rebound ratio. Rebound ratio. We divided all these, so we know we're going to divide. What goes on top? What goes on the top? Look at all the examples. What went on top? The what? What number went on top? The what? Because they're not all the same in centimeters. Some of them are in inches. What number went on the top? The rebound height. So rebound height over what? What went on the bottom? Drop height. Yeah. Now, I would tell you guys, this is going to come up all the way through this chapter. All right. So keep it handy. Right, Miss? And it usually shows up as part of the ESA for it too. So question like, what's the rebound ratio? All right. Now, that's 18. Are we good? Well, here we go. So now I have a question for you. This is where we're going to go to 31. So go to 31. It's in the next section. They were in here. Maybe they're not. A minute. I left them in here. Didn't check. Okay. Give me a second. I've got a question for you. When you bounce a ball and you let it just keep bouncing, does it ever bounce higher than what it started out at? Okay, give me a second. I'll be right back. We're going to test our theory. got a bouncy ball. Okay. If I were to let this ball bounce and just keep bouncing, do you think the amount that it keeps bouncing is going to get larger or smaller? Okay, well, what I'm saying is, if I will look at this and I drop it here and it bounces and it bounces and it bounces, don't have to write this down. If I told you that its rebound ratio, its RR, is 0.5, is it the same all the way across? Yes or no? No? Thinking. I've got somebody thinking. Well, let's check it. This is where I'm not sure it's going to work. All right. The one time his doesn't show up as the first one. Nope. Trying to get oh, I saved it. That's right. Where's my saved ones? Hold on. I'm looking for Mr. Anderson. I had it up yesterday. Why is it not coming? This is the oh. Sorry. My kids played with my tablet yesterday and deleted everything. All right, see if I can get it up from the here. Get it up on the. All right. Come on. Of course, no, it's not coming up. Why is it now not coming up? All right, well that.
Is it on YouTube?
Yeah, it's on YouTube and it's under. Usually I just type in bouncing ball and he's the first one that pops up. Not today. Why, oh why? Of course, I looked at it for the last 3 days. Nope. Oh, wait a second. He sent it to me too. Hold on 1 second. That's just weird. I've looked at it the last several days. I've told you, right? And the one day I need it, I can't find it. This is ridiculous. Come on. Okay, got it. Ah, now I know the name of it. There it is. Okay. All right, so here comes Mr. Anderson. So on a piece of paper, slow motion. So he's going to bounce the ball. We're going to test this. And that's at the bottom of the ball is at about 36 inches. So we're starting at 36. Okay, so write down 36. And he drops it. And okay, hold on. Let me rewind it. I gotta be on this side. Okay, so on the first bounce, it comes up to 27. So somebody, all right, so we're gonna make a table. Bounce, so it was bounce is 0, we're at 36. First bounce, we're at 27. Let's let it bounce again. Oh, he did it, hold on. Okay. Now it's coming back down, going up. Start it over. Okay, there's a 27. If we go back a little bit, looks like it's at 21. And I think this time it comes off the table. Yeah, it goes off the table. Okay, so let's look at our values. So bounce and height. So bounce 0 is the starting height. It was what? 30 what? 36. After the first bounce, it was at 27. Second bounce. And that's all we got, right? So let's check our rebound ratio. So the rebound height is 27 out of 36. So take 27 divided by 36. And I get 0.75. What if I do 21 divided by, would I do the 27 or the 36? What do you think? 27, because that's where the height was? Oh, 0.78 approximately. So is it rebounding at about the same amount? Would you believe that it would do that? Would you ever think that if I were to drop the ball here, I would catch it way up here? It would ever go higher? No. This is called exponential decay because each time it's going to keep getting smaller, right? So if we take these two and put them together, add them together and divide by 2, that's going to give us our average, right? Add them together. And that would be about, what, 76.5? Could I multiply this by 0.76 and get about the next height? What if I wanted to estimate what the third one would be? Well, these together is 0.75. And 0.78 divided by 2. Actually, I don't want to go there. Now, is our measuring techniques really accurate? No, they're not. In general, the rebound ratio for a bounce is always the same. All right. So let's say it was the 75. If I took 27 times 0.75, it would give me this. If I take it times 0.75 again, it gives me this. Could I keep doing that till it stops bouncing? Could I find out how high it is after the 10th bounce? Could I keep doing this till I get to 10? Yeah, I could. Because this one's bouncing, watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. Okay, it's going to keep bouncing. But if I wanted to go all the way down to 10, that's a lot. That's a lot of numbers to figure out, isn't it? So let's find a shortcut way of doing it. So if we look at this, I did 36 times 0.75, right? To get the first bounce. And then I took times 0.75 again. And then I would just keep taking it times 0.75. What would be a shortcut way of writing this? How can I simplify this part instead of writing point times 0.75 times 0.75 times 0.75? Ideas? No ideas? What's another way of saying 3 times 3? See what? Well, not third power. Oh, you mean this one up here to the third power? Yeah. Using exponents. Isn't that what exponents are? Is repeated multiplication. So I could say that this is 0.75 to the third power for the third bounce. What would be in front? The 36, the starting value, because we don't only use that the one time. What if it was the 6th bounce? What would I change? I would change the 3 to a 6. If I wanted the 10th bounce, I would change this 3 to a 10. So if this is what's changing, that would be our variable, wouldn't it? So it's our starting height times our rebound ratio. And I'm not going to use variables yet, rebound ratio, to the number of bounces. And we're going to clean this up for writing an equation soon. But for right now, that's what we're doing. And this is right here is what 31 is wanting you to get to. is writing the equation. Okay. Questions? So let's practice this. Let's write the equation for different things. So let's do an example. A ball is dropped. So I'll go with height. Should we pick?
Double digit or triple digit? Double digit.
Could be anything.
175.
Inches or centimeters?
Centimeters.
Okay. And it rebounds to a height of 90 centimeters. First thing, write an equation to model this. And 2, find the height after 6 bounces. Okay. I kind of gave myself no room here. Would you like me to put this on a separate piece on another so we have more room? Just give me a second here. All right. So what's the first thing we need to find to write our equation? The slope. It's not called slope. It's called the we need to find the rebound ratio. Okay. So how do I find the rebound? So step 1 is to find rebound ratio. Remember, the ratio is the rebound height over the drop height. What's the rebound height? Come on, what's the rebound height? How much did it rebound? 90. Over what was its height? What was the height it was dropped at? 175. Now we can leave this a fraction if you want, or do you want to change it to a decimal? I don't care. Probably decimal? Okay. So 90 divided by 175. And just give me a couple of decimals. Give me at least 3. So 0.514. All right. Now, from this, I'm going to write my equation. Remember, it's the starting height times the ratio to n. What's my starting height? It was 175 times my ratio 0.514 to the n. The n is the number of bounces, and this is the equation, and that's going to be your variable. So there's my equation. Questions on how to find the equation? Please, please, please speak up. Now I'm going to bring this equation up here. What's my variable? What's my n? Parker? And how many bounces do I want? So I'm going to put a 6 here. Now here's how you're going to use your calculator, guys. You got to use a calculator for this. If you're using my calculator, you're going to go 175, parenthesis, 0.514, parenthesis, this button right here, right above the divide sign, tells the calculator you need an exponent. I hit it twice. All right. It's called a caret. If you're trying to use your phone, it's tougher. You need to turn your phone sideways. Okay, hopefully, come on, turn. There we go. And it's this button right here that has an X and a Y. Okay. I don't recommend, I mean, this is for if you're doing it at home, but in here, please use mine. Because it's, and then you would put in the starting height. So then we just put this in our calculator. And we're going to get 3.227 centimeters. On your phone, you're going to put, let me put this down here. 175 times 0.514. Press this button here with the XY, and then you put 6. You'll get the same thing. Make sure you can get this on your calculator. Do you see what button, Miss L? Yeah. Okay. All right. So let's do 35 and then I'm done. You have 4 problems for homework, which is a lot of them are review. What's 22? 22 is solve the equations, review. 23 is calculate the slope and find the equation, review, right? 25 is write equations. Okay, and 36 is talking about what we just did. All right. So let's do our last one, which is 35. Okay, so everybody go to problem 35. So Deshauna and her team gathered data for her ball, and it's recorded in the table at right. So I'm going to put the table here. Now this is, they didn't let it keep bouncing. They just bounced it from different ones. So from a drop of 150, it dropped to 124. 70, 59, 120, 100, 183, 110, 92, and 40, 33. Okay. Part A, what's the rebound ratio? How would we find the rebound ratio? We've been doing it. How do you find the rebound ratio? This is the drop height. This is the rebound height. How are we going to find the rebound ratio? Help me out, guys. Yeah, we just need to pick one pair of points and divide them. It's not the same ball. It's not the same heights. Yes, ma'am. So 124 over 150? Yeah. And I wrote 125. Why did I write 125? Could I have used 59 and 70? Yeah, I could use any of the pairs because it just wants the ratio. So 124 divided by 150 is 0.827. I'm going to round to 3 decimals. So part B, what if the dropped height was 275? What would be the rebound? How could I find that? Well, let me ask you this. Would the rebound ratio be different than what it is already? So how would I do it? Santos, you got an idea?
Or what?
You have an idea? How would I find this?
I'm sorry, I don't know. We'll kind of figure this out too.
Okay, well, so the rebound ratio doesn't change, right? From the different heights, it's going to stay the same. So if we already have our rebound ratio, what would I do to this number with this number to get this one? Nikki? What? Multiply them. So take 275 times 0.827. And that gives me 227.425. So it should rebound that far. Now part C says, what if I know the rebound is 60? How do I find the drop? How do I work backwards? Any ideas? Marissa? Huh? Can you take a guess? So if I multiply to get this, the rebound, what would I do to get the drop? You divide. So we're going to take 60 divided by 0.827. And that gives me 72.551. All right. Part D. Suppose the ball is dropped from a window 200 meters up the Empire State Building. What would you predict the rebound height to be after the first bounce? So it's dropped from 200. What would be its rebound? Rena, you get it? What are you going to do? Mm-hmm. Okay. And that's 165.4. Well, part E says, how high would it bounce? Part D, so we're using part D again. On the second bounce and the third bounce. How would I find this and this? If I know after one bounce it's right here, what would I do to this to get to the next one? Multiply it by point. Yeah, multiply it again. And that gives me 136. I'm going to take that again times 0.827 to do the next one. All right. So whereas we've been working with functions that add the same number every single time, this whole chapter is going to be about doing what every single time? Multiplying. So we're multiplying by the same amount every time. All right. And that's the difference between a linear function and these ones that are called exponentials. All right. I am done. So you still have a little bit over 10 minutes. Start working on your homework. You could possibly finish it in class. All right.